So this algorithm basically have this 3 instructions, or let's say 4 instructions. So these 4 instructions are constant. So their complexity is order 1. And we have here the if statement is also order 1. So we can consider that all of this is order 1. Order 1. Okay? So let's make it order 1. Because it's constant. No matter how many instructions, as long as they do not depend on n, they're considered as constants. Now this constant operation is being repeated n times because I starts 0 up to n. Okay? So that's n operation. N operation, every operation is constant, so the overall is n. Okay? So this is order n. Now this order n operation is being repeated at most n times. Okay? At most n times. And I'm going to prove to you in a second why that's at most n times. But I want you to trust me for now, okay? So that's n operation. That's n operation. These are n operation. Every operation has n operation inside it. So that's order n squared. So the overall complexity of this algorithm is order n squared. Okay? So for example, if I have an array of size 1000 element, 1000 integer, and I want to sort it with this algorithm, it would take me 1000 squared. So that's 1 million. Okay? That's 1 million. If I have 1 million array, 1 million element, it'll take me 1000 billion operation. So that's 1 trillion operation, okay, which is very, very, very big number in terms of computer science. It'll take probably, I don't know, tens of hours or maybe hundreds of hours to complete. While in other algorithms, this 1 million integer array would be computed, would be sorted in a matter of milliseconds. All right, I promised you to prove to you, or at least give you an intuition, why this algorithm takes at most n operation for the outer while loop. Now we said earlier that our array is always comparing every element with the element next to it and sorting them, right? So we're sure at least the very last 2 elements are being sorted, okay? At least the very 2 elements. And every time we're adding an element, so at the very first iteration, we're sure that the very last element is sorted, and then the element before that is sorted, and then the element before that is sorted, and then the element before that is sorted, because we're always taking the maximum element and pushing it to the very right. And actually that's why it is called bubble sort, because it keeps always getting the maximum elements to the right. Okay, the biggest elements, it keeps pushing them to the right, just like a bubble. The bigger bubble goes first. So we're sure that at every iteration we're taking the biggest number and we're putting it in its correct place. And we're sure that this array contains n elements. So the worst case would be that every time we're taking that maximum number, taking it to the right, and then we're taking the maximum number, and then we take it to the right n times for all the numbers. So the maximum, the worst case would be that we do this n times for all the n numbers, okay? And every number pushing it requires an operation. For that reason, the outer loop takes n operation, and then the inner loop takes n operation. So the combination of them is n squared operation. Okay? So basically that's it. That's for this video. See you next time.